When it comes to virtualization, if you don't understand the background to exactly what you're trying to accomplish by deploying virtualization, then at the end of the day, there's really no point. If you don't understand the back-end processes, if you don't understand the logic behind it, the reasons and all that type of stuff, you find yourself sitting there going, okay, why should I care? And that was actually my take on it as well. It's like, why should I care about virtualization? What's the point? And then when a gentleman that I worked with took 10 minutes out of his day and he broke down virtualization to him, or to me, I was hooked. I mean, just his breakdown. It wasn't anything, anything extravagant. He didn't walk me through this elaborate PowerPoint or anything. He just stood there and he goes, "Do you understand the point of CPU, memory, NIC, and disk?" And I go, "Yeah." What if you could distribute those across multiple hosts at the same time? The same physical devices. That'll be kind of cool. Then he goes, "What do you think virtualization is?" I said, "Oh." It didn't click with me until he said that. Now, as I'm sitting here and I'm talking to you, I have several pictures in front of you that I wanted to go over and kind of break down the purpose between each one. Now, everybody's familiar, or if you've been working in IT for any stretch of time, then you're probably familiar with this look right here, where you've got your storage somewhere, and some network switches, network routers, what have you, some servers, some more network, some more servers, some more network, and then storage. So depending on the type of storage it is, will determine what type of switches you're going to connect to. Is it a fiber channel type of connection where you're going to need to use fiber optic cable to connect into a fiber channel switch to connect into your servers, which are running a converged network adapter? Or are you connecting via a iSCSI array, and you're using iSCSI or SCSI over IP, which is also referred to as iSCSI, to connect your servers connectivity that way? Either way would work, just depending on what type of end goal you have in mind will determine exactly which way you go with it. So, from that perspective, it's relatively straightforward for the most part. Now, what happens if you are physically running out of room? So every time you need to go deploy a server, you need to go in there and say, okay, well, I need to go figure out what it is that I need to deploy, what application am I going to be running at the top end, how much memory and CPU does that application need to run with, all that type of stuff that goes into play with it. So there's many facets that you have to know on the back end that you may or may not understand. So what virtualization does is, instead of you having to go out there and buy another physical server, instead of you having to go out there and license another copy of Windows Server 2008 or whatever it is you're trying to run on it, instead of having to do those, you can simply go in and create a new operating system. So you create a new virtual machine. And the idea with the virtual machine is it is going to share the resources of the actual host. So you take this right here, all this, the storage, the network, and the servers, you take all this and you start virtualizing it. And then you're able to put it into a virtual infrastructure up here. So you have your virtualization layer, which is this guy right here. We have your operating systems right here. And then we have our application layer right here, which is going to be the application. Now, a tighter look at it would be like this, where you have this is a bare metal hypervisor. So basically, the idea behind this is you take what they refer to as the abstraction layer. Now, the abstraction layer is going to be the part that actually takes between the guest operating systems and the physical architecture of the box. So, for instance, if you run a bare metal install of Windows 7 Pro, for instance, which I run on several of my virtual machines, I take that particular box and I spin it up, and if I'm going to do it on a bare metal physical device, then I have one operating system, so Windows 7. It's going to be utilizing all the resources for the entire box, so all the memory, all the CPU, all the network card, all the storage, and then on top of the operating system, which is what this piece right here sits, as the operating system is sitting there, you run all your applications on top of that. Microsoft Word, Adobe Acrobat, Google Chrome, whatever other applications you're going to run on top of it. You might be a developer, so you might be running some sort of, Visual Basic on the back end. However you're configuring it is, what you run on top of it is technically arbitrary. It doesn't matter. What does matter, though, is for every computer you're going to deploy. Now this doesn't go for end users. It can, but normally it does not. When you're going to deploy a new server though, when you're going to deploy it, you need to figure out, how many hosts are going to, how many guests are going to be connecting to it. What's going to be the need that is going to be applicable for it. And going out and buying a new server, it takes time for that to get shipped. Then you have to find a place for it in the data center. You have to physically cable it, run power, storage, networking, all that stuff to it. Make sure it's cooled correctly. And then you got to install the operating system, whether it's going to be you're going to do a Pixie boot over the LAN, or you're going to be doing some sort of, maybe you've got a thumb drive where you plug it in, you boot from USB, something like that. Regardless of what your methods of operation are, at the end of the day, the operation is still relatively the same. You need to figure out a way to be able to get new servers up and running as quickly as possible with the least amount of impact to your infrastructure. Well, that's the goal of virtualization. So the idea behind it, as we're going through these videos, is to keep going back to this piece. Now what I'm going to point out to you, and there's a reason why I have such a big picture for this, because I wanted to break it down for you. Now it says x86, which is going to be 32-bit. So normally the infrastructure that I run on is 64-bit. So architecture-wise, it really doesn't make much of a difference. But the idea of between the two different architectures, whether it's 32-bit or 64-bit, it's the physical aspects of it are going to be the same. So what you're going to do is you're going to take a physical machine. It could be I'm using an IBM server. It's a 2U rack mount server, and all I do is I take that guy, I put it into my rack of equipment, and I'll actually show you guys a picture of my rack as we're going through here, probably quite a few times. I take that rack, or I take the server, I plug it in, give it power, I plug it into a network cable, into a Cisco switch that I'm running here internally, which I'm a Cisco engineer as well, so a lot of that stuff comes into play. I take that, and what I do is I take a USB thumb drive that I've got as a bootable USB. I take that, I plug it into the server, and then as the server's booting up, I make sure to boot from the USB drive. Now, if I had the hypervisor sitting out somewhere on my share, and I had the ability to Pixie boot it, and I wanted to do that, I could, and then I could just boot over the LAN. But it's faster for me to do it over the USB. And then I go through and I boot up, and then ESXi installs. So once it's installed and everything's good to go, then I'm able to go in there and give it physically IP it, give it an address, a domain name, all that good stuff, and then I can go in and I can use the vSphere client to connect into it. Now, the cool thing about that, though, is before you even get into all the details of configuring it, giving the IP address, and all that type of stuff, what it's going to do is the entire physical layer, which is going to be this piece right here. This physical layer, the entire box has all the CPU, all the memory, all of the network, and all of the disk. Now, disk is going to be what we're going to, for the moment, refer to as what's actually the hard drives that are physically inside of the server, or directly attached storage. So this is going to be the hard drive, like if you have a laptop or a desktop computer, that's going to be the hard drive that's physically sitting inside of your computer. So what this means is all of these devices are going to be taking a portion of these resources and utilizing them. Now, the virtualization layer, or the abstraction layer, this is why VMware is so powerful. Because when you look at it from a high-level overview, what you're doing with virtualization is you're taking all of the hardware resources of the hardware, so the CPU, memory, network, and disk. You're taking all those pieces and you're able to carve them up or virtualize them, so make them available for more than one operating system. So when you're looking at ESXi, so when you're in the vSphere client, you're looking at it, and you click on the host, and you look at the summary, which actually I have pulled up right now. So this is my host, and right now, as you can see, I have a bunch of virtual machines installed and ready to go. But as you can see right now, I have 64 gigs of RAM that I have available, and I have 8 processors at 2.8 gigahertz apiece. It's actually 2 processors, 2 sockets, and I have 4 cores per socket, which means I have a total of 8 sockets, or 8 cores that I can play with. And I can and that means I also have 16 logical processors. This means I can virtualize all this up, and I can divvy it up to all the different virtual machines. And that's what I end up doing. I give it, so let's say here I click on CCIE. This just happens to be an IO, or it's a Linux box that I have running. And right now I gave it 16 gigs of RAM. I gave it 3 vCPUs, and so that's running. And then if we go down here to click on Cisco UCS, and I gave this guy 8 gigs of RAM and 4 CPUs. The V means virtual, so we take that into play. Now, what this does is it allows you to specify in the virtual machine settings, and each one of these guys right here is a virtual machine. So we have 5 different virtual machines. Actually, there's technically 4, and then you have this would be the host's service console. So this is basically vSphere controlling what the rest of the box does. So I've taken you can, or somebody else could. You take a portion of all this information right here, and you are able to divvy it up. So you take a certain amount of this, a certain amount of this. Actually, let me make this a little bit go red and make this a little bit thicker, make it easier for you guys to see. So you take a portion of the CPU, you take a portion of the memory, a portion of the network, and a portion of the storage, and you hand it off to this guy. You take a little bit of this guy, take a little of this guy, a little bit of this guy, and a little bit of this guy, and you give it to that guy. Now, the interesting part about this now is memory is able to be spoofed, network is able to be spoofed, and so is disk. The reason I say spoofed is because it's made to look like something either less than it is or more than it is. 99% of the time it's going to be less than it is. You're not going to give every operating system the entire disk space. You can, but normally you're not going to. That's why I usually say spoofed as to less than it is. You cannot spoof the CPU. This will show up as it normally is, physically handed off to the router, or handed off to the virtual machine. So whatever the way it looks inside of the what do you call it? Inside the ESXi host, whatever it looks for here. Let me click back on my client. Whatever it looks like here. So we have Intel Xeon CPU X5560 at 2.8 gigahertz. This will look the same as it will in a virtual machine. However, the amount of how much of that particular CPU you've actually handed off to the virtual machine can be different. But the actual processor type doesn't change. It's the back-end stuff, like how much of the CPU has actually been handed out to that particular virtual machine. So we have that piece, and then again, all the CPU, memory, network, and disk all continue to be handed off to more and more operating systems up to a certain limit. So usually your limit is going to be the amount of memory you have on the box. Now, with that being said, I'm going to take you over to this guy. I'm going to come down here a little bit. Now, with all the capabilities, right? Yes. Actually, I'll come back over to here. So, what this diagram right here pretty much represents is the ability to connect your ESXi host. So this is a host, this is a host, and this is a host, right? Now, with that being said, on the back end, and you're going to, in the physical servers, you're going to be able to set what we refer to as the virtual networking. The virtual networking, or the vSwitches, that comes standard with every ESXi host, are going to have different VM kernel ports, which is a logical layer 3 interface, and then we have VM kernel or VM port groups. A VM port group is basically going to act as a switch, and what you end up doing with that guy is you put the virtual machine's network card into a particular VM port group, and that's how they're able to talk to each other. You can have multiple Ethernet virtual network cards associated to different virtual machines. So let's say, for instance, if a virtual machine 1 has 3 virtual NIC cards, and each NIC card is in a different VM port group, which means they can talk to different networks. So that's how you can split up how things operate on the back end. So you take that, and one of these particular virtual machine port groups happens to be connected to your iSCSI environment. Your iSCSI is going to allow you to run SCSI storage, and you're going to be able to run that over your IP network, which means your already in place IP network. So your Cisco switches connecting to your HP servers, for instance, and your HP or your EMC or your NetApp storage array. So regardless of how you want to cut it up, and I'm actually using a virtual storage capability, and I will show you guys how that works coming up in a future video. But the idea behind this is you connect all three of these hosts to a single storage type, which they refer to as a shared storage. This is different than directly attached storage. Directly attached storage is the physical drives that are plugged into the machine here, which you make these guys look like. So when it comes to this guy, this is referred to as SAN, or Storage Area Network. SAN allows you to take a portion of this, so we'll take this block right here. This square that I just highlighted will actually be able to divvy that amount of hard drive space and hand it up to this guy. So basically the SAN is able to virtualize its hardware resources, so it's hard drive. Then you take this guy right here and you hand him off to this server. So that's his SAN capability. And then we'll take this guy right here and we divvy him up and we plug this guy into here. And then that's how that would work. So you connect into, and I'll show you guys how this works. Usually you're going to have a dedicated layer 2 network connection between your server and your SAN array, and that's going to allow you to connect your boxes to the storage array. And what end up happening from here is, by doing this, is whatever happens on this server would be affected by this server. So now let's assume for just a moment that you don't have an ESXi vCenter server set up. What that basically would mean is if you don't have vCenter server enabled, you wouldn't be able to do anything like vMotion. You wouldn't be able to do anything like storage vMotion. You wouldn't be able to manage all of your hosts from a single pane of glass. Basically, vCenter server is a way for you to manage all of your ESXi hosts from a single location instead of having to log into each one individually. Now, I'm actually going to skip ahead a little bit here. This right here would be how, this is what we refer to as vMotion. Now, remember what I just said. We have an ESXi host here. We have an ESXi host here. We have the internal networking setup and the storage setup so that each of these ESXi hosts can connect to a different storage type. So we might have a local storage here and local storage here, and then we might have a shared storage capability. So basically the idea behind this is if this ESXi host is not connected to shared storage and this one is not connected to shared storage, things like vMotion would not be able to happen. The idea behind vMotion is that when you have a virtual machine, you take and you install the virtual machine's hardware, the hard drive and things like that, are actually the hard drive and all that other stuff, all the VMware files are actually sitting over here in shared storage. So what you end up doing, in order for vMotion to happen, you would move, the hard drive wouldn't move anywhere. Neither would any of the CPU. The CPU would be staying here. The idea behind it is all of the stuff that can't be virtualized, the hard drive space, that's got to stay in shared storage. So what you're going to do is from this guy, you would be talking to this guy, and you would use vCenter's vMotion capability to move a virtual machine from this host to this host. That means that it's going to remove its locks. So this vSphere client, this ESXi host will remove its memory and CPU locks from this guy right here, and he will have vCenter, because vCenter is managing it. Well, vCenter will say, okay, ESXi host 1, I need you to release your memory and your CPU from this guy, and I'm going to migrate, is what they refer to it as. I'm going to, it's the actual command is migrate. I need to do a vMotion from you to another host. So what he would do is the vCenter would say, okay, ESXi host 2, I need you to lock on, he would tell this virtual machine here, I need you to lock onto this guy's RAM, this guy's CPU, and that's where you're going to be going. So then you're able to move this virtual machine from here to here. Here to here. And that's how you would do that. That's what vMotion is. Now this is a layer 2 network. They need to be layer 2 connected in order for this to happen. Now this is ESXi 5.5 and below, meaning 5.5, 5.1, 5.0. They all work relatively the same way. Now let me scroll up here a little bit. When we get into ESXi 6.0 and newer versions, you have the ability to vMotion between multiple vCenter servers. You don't have to be going... Now, this is one vCenter server here. Up here we have two vCenter servers here. The difference between the two is that you need to be able to talk between the vMotion servers, and they have to be in the same single sign-on domain. They could be two different vCenter servers, though. So you can vMotion between them. So, again, the same characteristics for the most part apply. And I don't know all the details on the back end for ESXi 6.0, but they're relatively they're somewhat the same, I should say. Now, what would this look like in the real life? Well, right here we have our EMC array. Right here. Actually, no, I take that back. That is not the EMC. EMC is right. Actually, technically speaking, it's all EMC. I had to take a closer look at it. This is all EMC. Now, I don't know if you guys can tell this or not. I can see it in my drawing. But the way that this actually looks right here, you have an array here, you have an array here, you have an array here. And I don't know if you can tell, but this is the actual JBOD, or just a bunch of disks here, and just the JBOD here. So that's how that would be breaking down. And this is just how they're physically laid out. And I believe these are some more hard drive space down here. And I can't tell 100% off the top of my head by looking at it, or those might be servers. I do believe this little silver thing right here, I believe those are Dell servers. Same thing over here. I could be wrong, but I believe that's what they are. Now, this guy right here, I don't know if you can tell it or not. That right there is a Cisco UCS server. This is a B series server, and the reason I know that is because B series are the blade. C is for C. It would actually make sense to have it. C is rack mount. B is blade. At least that's what I'm familiar with. And I don't know if you can tell us or not, but we have some Ethernet cables or fiber cables running out this way. My guess, and this is just a front-facing picture, I don't know for sure, is that these fiber cables are connected to either the fabric interconnect or a FEX. What basically what those are is a fabric interconnect allows you to connect your fiber channel connections between the server and a fiber channel switch back to your the rest of your data center fabric, which could be your servers and some other details on the back end, or it could be a FEX. What a FEX is, a fabric extender. What that is you would be able to take this is what they would call as a top of rack or a TOR switch, like a Cisco 2200 series fabric extender, and you would connect that back into what they refer to as an end of row Nexus 5K, or you could do it in Nexus 7K, however you want to set it up. Nexus 5K and Nexus 7K. This guy right here is a 1 or 2U rack mount. This guy, actually technically they're both rack mount servers or rack mount switches, but this one is simply this is a single or double U, and this guy right here would be a chassis. Okay, there's a chassis switch. Now the Nexus 5K would connect down to the Nexus 2K, and the Nexus 5K and Nexus 7K would configure effects, a fabric extender port, fabric extender, and he would actually connect into down to this guy, which I'm assuming this is a FEX. I can't tell from the picture what it is, but the idea is that the Nexus 5K would have a connection down to this switch right here, and he'd be able to connect into the server from there. And so that you would connect your servers into the FEX, and then everything else would be good to go. And that would give you 10 gig, 20 gig, 40 gig uplink capability. So it's much, much faster than connecting it to like a Cisco Catalyst switch using iSCSI. Cisco, like a Catalyst switch, wouldn't have the backplane nor the forwarding capability that a data center Nexus switch would have. So that's the general idea of how that would work. And then you can get into other things like, virtual port channels, and you can get into fabric path and all the other cool stuff that comes into play with how the Nexus series of switches comes into play. But I just wanted to give you guys an idea of how that would look. And now you might be saying, okay, well, where does the VMware piece come into play? I'm glad you asked. The VMware piece would actually be running here. This is where ESXi would be sitting. ESXi would be sitting on either one of these blades sitting here, and they'd be sitting on these blades, and what they would do is each one would be a different host, potentially. And you could have, say, host 1, host 2, and host 3. I'll just draw a line to each one, and then you go down the gamut, and this would have, this would be .1, .2, and .3 respectively, and that's how you would connect it into your virtual environment. So they would be running, ESXi would be running on the blades here. And these are half width blades, I believe B200 series, and then the B200 series on the back end would connect into the FEX. The FEX would connect into the Nexus 5K or 7K, and then the Nexus 7K or 5K would be also connecting to your storage, like your fiber channel switch stuff on the back end. So on the back end there would be some cables ran and plugged into here into a storage processor or into an initiator or a target. I'm sorry, the initiator is on this side. The target is over on this side. So that'd be how you would connect all your data center into your storage array, and that would allow you to vMotion from here to here and be able to go along as you're going there. So that's pretty straightforward for the most part, but it's important to understand the processes on the back end to how it's all put together. So as we go through our series, and it's going to take a while for this thing to get kicked out, but as we go along and get everything situated, we're going to be taking a look at all the stuff from a standalone host, and then from there we'll be able to take a look at doing things from a host that's sitting inside of a vCenter environment. Because I've dealt with customers that both deal with a standalone client or a standalone host and a host with that's inside of vCenter. Now there's a question here: how would you manage it by itself? Well, and the general idea for this guy is, let's say I'm here in Milwaukee, okay, and I have my Milwaukee. I've got my server sitting here, and I connect into it. Here's me. I've got my little cowlick hairdo, and I'm on my computer right here, right? And I connect into the host. I'm on the vSphere client right here. I connect into this box, and I'm doing whatever administration I need to do, and I've got my virtual machines running, and I've got my storage array set up on the back end to do all the storage, right? Well, I'm a small company. I have, say 20 VMs, right? Well, the idea on the back end here is, let's say I have an office in Chicago. Okay, and he's also running here. He's got his storage set up here. He's got 10 VMs because he's a smaller office. I connect into my computer here, and here's my coworker. We'll call him Tom. I don't actually work with anybody named Tom, but who cares? So, and he's also doing his administration through vSphere to the host. These guys aren't talking to each other. There's no connection between these two hosts. I'm going to help you walk through how you would do stuff like that, how you would export a virtual machine to an OBF or an OBA file, and then let's say, for instance, you need to, you've got all of your developers are moving to your Chicago office, okay, and you need to move all of your database and your dev environment from your on-site setup to over here, and you needed to have that done in, say, 2 days. Well, instead of having to go out and set up a VPN, try to do vMotion across, which isn't going to happen, what you could do is simply export your virtual machines to an OBA format, and then either load them up onto a hard drive and drive them to Chicago, or you could simply do a copy from one host to another host, and this would be to to a storage array, and then copy that and upload them back in. It does take time. That's why this is one of those reasons why you might want to have vMotion enabled. We'll talk about some of the other characteristics that go along with that. Now, if you have a very large environment, draw a bigger one. Here you're still in Milwaukee, but you work for a bigger company. Let's say you have several hosts. And then each one of those connects into a shared storage. And on the back end here, you have a vCenter server. I'll just type in VC for vCenter. You have your SAN. And then you have me. I'm sitting on my computer, and I'm a happy guy. I sit on my desk all day. I've got my cowlick is sitting down today, and I got my several virtual machines sitting on here with whatever else I've got going on, and I'm noticing that this server is way underused. This server is way underused. And actually, let me add another guy there. So make it 6. So, and I have this server is way underused. Well, what I could do is I could go in here and I could say, well, I could set up things like storage DRS, distributed resource scheduler, and I could be taking a look at my utilization as we're going throughout the day. And my boss can come to me and say, hey, how come host 2 and 3 are at, say 20% utilization, and host 1 is at, say 80%. And I could be like, well, that's because we have, a bunch of dev guys doing their programming and whatnot. And he goes, okay. Which normally what you do, this is before your boss even comes to you. With storage DRS, you could actually go in here and set up in vCenter that when you have, say, 80% utilization on a particular box, you could tell vCenter to move a virtual machine from one host to another host. This is to balance it out. By default, it's going to try to load balance it, but at the end of the day, it depends on how you want to do it. You could have it do it automatically. You could have it do it, you could manually do it. It just depends on what you want to do. And that also falls back into what they call distributed power management, or DPM. What DPM does, it's similar to what storage DRS does, but what actually take a step back. It's not just storage DRS. It's DRS in general. There's also the capability of moving from one storage type to another storage type. We'll talk about that. Same thing with storage vMotion. So, distributed power management, what that guy allows you to do is, let's say, for instance, you went from, it's the end of the night, say at 8 o'clock, 9 o'clock at night, all your web traffic has settled down to very, very minimal usage, and now you went from 80% down to 10%. Now you're there, you got all these hosts, all these virtual machines just chilling on your host, not doing anything. Well, you could rely on DRS to move them to another host, but that's not actually solving the problem. That's just moving the issue. You're not actually attacking the root cause. You're attacking a symptom. Symptom is it's not being used. It's taking up memory. It's taking up CPU. It's taking up power. So, what could you do about that? Well, you could use a thing called distributed power management and go in there and say, well, if it drops below, if any virtual machine that's running web services in IIS and has, a database backhaul for pulling up, web traffic, if any one of those particular VMs runs below 10% utilization for, more than 20 minutes, I want you to power it off. So you set up DPM, so I'm going to power off when we hit 10%, and then this guy gets shut off, this guy gets shut off, and this guy gets shut off. So now we're completely load balanced across going across our entire environment. We're good to go. So you take that into play. Now in the morning, when you start spinning up and you're 20, and then you start jumping up to 30, and then to 40, and then so on, throughout your day, you can actually start powering virtual machines back up. So you can keep them off until you need them. Amazon AWS has a similar concept of what they call Elastic Cloud. Elastic Cloud, or EC2 as it's referred to, does something very similar to that. Is it won't turn on the boxes unless there's a need for it. And when they don't need the boxes, they'll turn it back off. That's what they call the Elastic Cloud. It's able to expand and contract with the needs of the network. So that's the general idea of how that would work. So we're going to be taking a look at all these capabilities, and then things like host profiles and storage profiles and some other things that are a little less common. And once we get through all of our 5.5 parts, because 6.0 just came out like 2 or 3 months ago, as far as I'm aware, I've got it downloaded. All I have to do is deploy it. Once we get done with 5.5 and completely walk through it, then we're going to add in 6.0, because I'm actually working on getting I want to upgrade my VCP to 6.0, and then work on getting into the VCAP. So we have those capabilities as well. So we're going to take a look at these different options and capabilities as we go along, and I hope that me breaking this down helped you guys understand more of the generalities of how this goes, and we can go from there. So I hope this has been informative for you, and I'd like to thank you for viewing.